This is part 5 of the Chapter 9 review, and we pick up with problem 37. And in 37, we're going to solve for the two angles x and z and side xy. We can use Pythagorean to find side xy. So in 37, we'll have xy squared plus 18 squared equals 25 squared. Xy squared equals 25 squared minus 18 squared. Xy equals the square root. 25 squared minus 18 squared. Xy is approximately 17.3. Now, we're going to find x, some old horse. We can use sine to find angle x. Sine x equals old horse, 18 over 25. Take the arc sine of both sides. X equals arc sine of 18 over 25, which is approximately 46.1. And now to find z, caught a horse. Again, I don't want to use a calculated value to find any angles, any approximated values to avoid compounding error. Caught a horse. So cosine of z is 18 over 25, a horse, a horse. Take the arc cosine of both sides. Z equals arc cos of 18 over 25. You're always going to use arc functions to find the angle. So that's approximate 43.9. And now let's move on to problem 38. In problems 38 through 40, we're given some partial information about the triangles, and at least in 38, we know that the triangle is not a right triangle. So we're fairly comfortable with finding the areas of triangles in general, but when we have some strange values given and only limited information about our sides and angles, we have some problems that come up. Now, before we get into this, I want to look at, real briefly, the idea that we looked at in class about how to find the areas of triangles using trigonometric functions. So let me pull up a little picture here. And here we have some triangle that's not necessarily a right triangle, A, B, and C. And H is this particular height of the triangle, but we could also draw another altitude from vertex A to side small a, and that would also be a height of the triangle. To find the area of this triangle, we know it's 1/2 base times height. But if we're only given partial information and we don't have enough information to calculate exactly the height of the triangle, then we have to use some trigonometric functions. And so the 1/2 the base, for example, if we start at this angle, 1/2 base is 1/2 side B times the height. And this height would be some old horse. Sine A of H over C. And solving for H, we would have C sine A. So C sine A is actually the height of this triangle. Likewise, if we were given this angle, A sine C, A times the sine of C would be the height. And if we were only given one of these two angles, or specifically this angle, we would have to find this height, this segment here, which would be C sine B. So it would be that side sine of that angle. So we'd use trigonometric functions to find the area of the triangle. So in each one of these, that's what we're going to have to do, is figure out which one of these versions we're going to be using. So let's go ahead and draw a picture and see if we can represent number 38. So let's just randomly put in a picture here and call it A, B, and C. They're giving us angle B, which is 124, and angle side A is this side, which is 9, and side C, which is this side, is 11. So what we're going to have to do is we're going to have to use this altitude as the height. So our area is going to be 1/2 base. This is going to be the base that we're going to use. 9 times C, this side, times the sine of B. Sine of B. This is going to be this third piece here. So we would have 1/2 9 times 11 times sine of 124. And let's figure out what that comes out to. It's going to be approximately 41.0. And this, by the way, is 38. Just as a recap, when you set up a triangle, small a is always opposite angle A, small b is always opposite angle B, and small c, side C, is always opposite angle C. So that's how I labeled this. And just because they gave us this angle and this side, I knew that I had to use either this is a height and this is a base, or this is a base and this is a height. And that's why I came up with this form. So let's go on to 39. So let's draw it here. And again, I'm going to draw just a general triangle. A, B, C, A, B, C. And our labels, angle A is 68. So this is 68 degrees. B is 13, and C is 7. So I'm going to use this as a height, and the form I'm going to have is the area is going to equal 1/2 base, which is 13, times C sine A. This is some old horse. So this is in the denominator, so it's going to be 7 times the sine of 68. 7 sine 68. Using this form up here. All right. And working this out, we come up with 42.2. Again, this is it. I know it's kind of cryptic, but you'll get used to it after a little while if you just draw out these relationships. So this height is sine 68 equals h over 7. So 7 sine 68 equals the height, and that is why I put that here. So now we have 1/2 base times height. All right, now let's do 40. And we have another triangle that we're going to draw here. Same labels. And they give us C is 79 degrees. A is 25, and B is 17. So our area is going to be equal to 1/2. This is going to be our base. Again, this is going to be our height. 1/2 base, 17, times the height. Now the height there is going to be, let's do it up here if we could, sine 79 equals h, some old horse, over 25. So 25 sine 79 equals h. So this is going to be 25 sine 79. And that's going to be this piece right here. That comes out to 208.6. All right, let's move on to problem 41. In problems 41 through 46, they're asking us to solve for these triangles, and they're giving us a very limited piece of information with each one of the triangles, which means that we're going to end up having to use the law of sines or the law of cosines, or in some cases both, depending on what we're looking for. Now, I warn you ahead of time, this is going to be very tedious, and it's going to be time consuming, but it's going to be good practice. If you can get through these 6 problems, then you should have a very good handle on how to use law of sines and law of cosines. But it's not likely to be a whole lot of fun. So let's get started and see where we can get to. So for problem 41, let's go ahead and draw the picture. Just like always, I'm going to draw a triangle in here and label it A, B, C as usual. A is 112 degrees, little a is 9, and B is 4. Now in this case, I don't have enough information to find any of these other 2 angles. So I'm going to have to use either the law of cosines or the law of sines. Now, I can probably use the law of sines because I have an angle and a side opposite. So I should be able to use the law of sines to find this angle. So let's go ahead and give that a shot. And the law of sines is sine of A over A equals the sine of B over B. So sine of 112 over 9 equals sine of B over 4. We're going to multiply by 4. 4 sine 112 over 9 equals sine B. And to find B, I'm going to have to take the arcsine of both sides. So arcsine of 4 sine 112 over 9 equals B, because I took the arcsine of both sides. Just arcsine of this side, arcsine of this side. And these cancel each other out to give us B, and here we have that. Now there's a reason that I'm doing this in this fashion, because if you can possibly do it, you should get used to entering your values at one time into your calculator. So you're reducing your amount of error by having to retype or to write and get a transposition error in these intermediate values. All of these values are going to be approximations, so the last thing you want to do is drop some decimal places or to miswrite something. Now yes, this takes a little bit of energy to get used to entering a complex calculation like this. You have to get used to using parentheses in your calculation so that you keep things straight. But Once you learn how to do it, it's going to be very, very helpful to you. So I'm going to work this problem at the beginning of the next video.